Okay, we're now recording. 33, 35. Okay, let me take care of that question. Oh, I was right there. Okay, let me go back. Here we go. For 33 and 35, it's kind of open-ended. Trying to think how I might ask as a multiple choice question. I might not ask that question, actually, the more I think about it, because it's too open-ended. But the way you would do it is you could say like f x equals x, g of x equals x plus 1. Now, are those continuous functions? They are. They're both linear. These are both continuous. And I can say h of x is root x. Is root x continuous on its domain? It is. So all three of these are continuous functions. Now, how do I combine it all as a composite? I can do this. And there we go. That's good enough. That's all I need to do for 33. Now, you could have done it a little differently. You could have done this if you so desire. You could call f of x x over x plus 1. And now you're seeing h of f of x. Is this continuous here? It is on its domain. Rational functions are continuous on their domains. And composite, you have two functions. We have one inside the other. The combination of that is going to be continuous as well. You can do something similar for 35. 35, you can say f of x is 1 minus x. That's continuous. That's linear. G of x is cube root of x. Cube root, why not? That's continuous. Cosine x, we know that's continuous. And if you combine it all, you do it as a double composite, h of g of f of x. And that will be continuous. Because all the other individual parts were. So, but it's a little open-ended, so I'm not sure if I'll ask that on the test. I don't really. Plus, I think it'll be a kind of a night retrograde, so we'll not do that. Okay, so that's what number 5. I'll do that in just a sec. Page 97, number 5. That's a limit problem. I'll go over that in just a sec. General question here: how can you look at an equation and know if there's a jump or infinite discontinuity, or will we just know from graphing it? I think graphing is probably gonna be your best bet, but that's what I would suggest you do. Let's actually look at 1 through 9 on page 80. Page 84 to help you with that. I'll do that after I do number 5 on page 97. And also number 5, page 84, how do you write the discontinuity of the domain x greater than or equal to -3/2? Yeah, let me go through, I'll go through 1 through 9 on 84 in just a sec. Let's do page 97, number 5. Someone just asked about that. Okay. Ooh, good one. That I like a lot. I will definitely put, just so you know, that is definitely making the cut for the test. And probably 6 or 7. Some combination of number 8 probably will make the cut as well. And probably, now 1 and 2 are too easy. Or maybe I'll just give you guys a gimme, like 1 or 2, we'll see. Let's go over 5. What you want to do is this. If you plug in 0, you have a problem. You have 1/2 minus 1/2 over 0. 0 over 0 is not okay, not good. So what do? You find the LCD. LCD is that straight up, right? Multiplies by 2 plus x. Multiply this by 2 plus x. Multiplies by 2. Multiply this by 2. Clean it up. You have 2 minus parentheses. Make sure you put a parentheses. Negative outside the 2 plus x. Otherwise, you're going to get something incorrect. Down below is 2 times 2 plus x. Meanwhile, the whole thing's over x, which I'm going to write as x over 1. We clean it up more. If you clean it up a tad more, geez, I didn't leave myself enough space here, did I? You're going to have negative x up top, and 2 times 2 plus x. And this fraction here, which is you're dividing by x over 1, is actually times 1 over x. These x's cancel, leaving behind negative 1 over 2 times 2 plus x. Now I can plug in 0 for x, and I will get negative 1/4 over here. So I would probably maybe set this up as maybe multiple choice, or as a fill in the blank. I don't know. We'll see. But you still have to show me the work. I still need to see your work to give you full credit for it. If you just give me the answer, I'll probably just give you a point because at least you knew how to maybe plug in your calculator or something. But I need to see the work. Now, if you got it wrong, but all your work is great, and let's say you made this error, and this happens a lot. Let's say you had this. You forgot to put the negative next to x, so you have positive x instead, and you put 1/4 as your answer. I'll take off a half point. Not a big deal. If it's a 4-point problem, I'll give you 3.5 out of 4. That's fair. So don't worry if you make careless mistakes. It happens to all of us. We're human. I know some people tend to make careless mistakes more frequently than others. I was one of those people in high school because I was just, again, I worked very fast. I sometimes don't take time to stop and reflect on what I've done. But you can always plug in your calculator Desmos to kind of double check. Because in Desmos, you would see, oh, wait 1 sec, it's not positive, it's negative 1/4. So don't worry, but do submit your work after you submit the test. That will help you out. All right, we're going to go to page 84, 1 through 9, because someone asked about that. Number 14, okay, let's talk about number 14 as well. But let's go back to 1 through 9 first. Okay, clear my screen. Go back. All right, looking at 1 through 9 on page 84. The best way I would handle these questions is to just graph them. If you were to graph this, you see something like this over here. And so you would know it's an infinite discontinuity because y is going towards infinity on the other side of the asymptote. So, and it happens at -2. If you're to graph this here, that's going to be a nice smooth curve. I think it kind of looks like this for number 3. You don't have anything. So to answer the question, how should we go about these? Just graph them. I'd probably be explicit about it in the test. I'll say, through graphical techniques, what can you say about what's happened about this graph? And maybe I'll make a multiple choice question or something. For 5, I know someone asked something specifically about 5. How do you write the discontinuity of the domain? That's a weird one actually for number 5. I guess it's just not continuous. I mean, obviously nothing's continuous if it's not part of the domain, right? So like for number 5 here, it starts at -3/2 for x and does this. So where is it not continuous? Any x value, so not continuous at any x value less than -3/2. Why? Because it's not defined there. Like, is this continuous at x equals -2? No. Why? Because f -2 does not exist. So I think that's what we're trying to say there. Any point not in the domain is where it's not continuous, which is always true for continuity, right? If you can't find the y value, it's not continuous. So that's why I think graphical procedures are probably going to be best to approach these problems from. Because you can kind of see, well, yeah, it's not continuous if it's not proper domain. 7 we saw in the notes in 2.1, I think. We saw something that looked like this. Clear is not defined at x equals 0. And it's a jump because the limits don't exist. The left and right hand limits don't meet up. And plus, you just look at it, it looks like it's a jump. And here you have a vertical asymptote at x equals 0. For now, if you were to graph that one, you'd see that. In fact, I think it looks kind of like this. And that's that. Or I think, I don't know, actually, how it looks. Let's go does this really quickly. Not 100% sure. Okay, whatever. But definitely, we have vertical asymptote there. So I'll leave those ones open just in case. All right, someone asked about 14. So let me go over there. At what values of x is f continuous? 0, 1, and 2. And someone's curious why it's continuous at 0. I don't know. It's not continuous there. Wait, let me read that one more time.
I think it says like everywhere between, like it's kind of above. It's like everywhere between like -1 and 3, excluding 0 and 1, 2.
Or was that what?
Like it's kind of above.
Oh, sorry. Okay. This is what happens. You know, see, I told you guys, I'm not thorough enough. I work too fast. All right. Everywhere in that interval except, right, exactly. So hopefully that answers the question. Someone was asking, let me look at the chat one more time. Maybe you were thinking of the same thing I just did. Yeah, it's not continuous at 0. Yeah, of course not. And definitely not 1 or 2 either, right? And I think that's just obvious. F is 0 is not defined here. For 1, f1 is defined. The limit is also defined, but the limit does not equal f of 1. And 2, f of 2 is just not defined. So, okay. Thank you, Zoe. I appreciate you being correcting me there. Okay, I am going to work on 45 in just a sec before I put you guys in breakout rooms. Any other questions you want me to tackle before I do 45 for you guys? Okay, let's talk about 45. Excuse me. By the way, 51 is also a good IVT problem. So what I'll wind up doing, maybe during one of my breaks, I'm actually giving a test my stats class, so I'll have an opportunity to do that. I could probably write out solutions for 45, 46, and 51 so you guys see how those look. Because they don't really write the solutions there for that. And by the way, don't hesitate to use Slater. I'm just going to kind of just call it out. You know, it can actually help you. I mean, of course, don't copy homework mindlessly from Slater. You're only hurting yourself when you do that because you're not going to do it on the test if that's all you're doing. And I'll know. So, but you know, but still, it's a good resource to have in case if there's some worked out solutions that I forget to provide or don't provide. Of course, if you ask me, I'll do it for you. But if you need something that's more real time or on demand, that could be a good place to go. Just so you know. Okay, let's take a look at 45. I think I have a little space off to the right here. This is my, I can tell, just got a new dining room table, so I have all this nice little space I can write on. So 45, is any real number exactly 1 less than its 4th power? We translate. Is any real number called x exactly, I'll put equals, 1 less than its 4th power? So that's going to be step 1. make the equation. Now, I did, in School G, give you a hint. And I asked you to follow example 11 of the 2.3 notes. Here are the 2.3 notes. Here's example 11. The notes are your best friend. They're going to help you tremendously in this class. That's step one. You write the equation. And now I'm going to do step two. Step two is we're going to put 0 on the other side. So, hold on. We got step two. We're going to rewrite it like this. Very easy, not that hard. Easy peasy, right? And that's just move all terms one side. Move all terms one side. Step three. Give the expression a function label. So I'll say let f of x equal, hence, the question changes now. So we just changed the question around now. So again, you translate, rewrite the equation by moving all terms one side, and give the expression a function label, like f of x equals this. So now the question becomes, can f of x equal 0, right? That's what we're trying to prove. There's a question in the chat. Let's see if it's about this. I will tell you to use IVT. So someone's asking, how do you know how to use IVT here? Yeah, it's a little tricky. I think once you know your theorems really well, and once you get more comfortable, like we're going to revisit this kind of problem in a few months, and also in the AP, they like doing this. You'll know once you get comfortable with theorems. For now, it's not very obvious, so I'll tell you. I'll explicitly say use IVT. That's one more problem with textbooks, that they sometimes don't do that. That's why the hints are going to help you a lot. I even say right here, use IVT. So make sure you follow my hints, because the textbook sometimes is too vague, but I'll be more explicit with you guys, so don't worry about that. All right, step 4. Step 4 is a big one. Think of 2 x values for which f of x is positive and negative. So you make a little table. Usually 0 is a good one to plug in first. And I get -1. Remember, this is my function here. What if I plug 2 in? I get 16 minus 2 minus 1, I get 13. There you go. So now is the final step, step 5. That's kind of the big one. You put it all together. And here's how you want to say it. Or you could say it this way. Since f of x is continuous, And you could probably say all polynomials are continuous because it is a polynomial function, right? Since f(x) is continuous, and that f of 0 equals -1, and f of 2 equals 13, then by Ivt, f of x equals 0 on the interval from 0 to 2. That would be sufficient as a statement. 3 things I care about in the statement. I care to see that you're saying continuity. I care to see that you have found some y values. One's negative, one's positive. And then your final statement where you quote the Ivt. And of course, you know, our statement is that f of x will equal 0 because that's what the question has now become. And because you found an interval where it works, any y value between 0 and 2 for x will be taken on. That's what Ivt tells us. Because the graph looks like this. You have a point right here. You have a point right here. It's continuous. So clearly y is going to equal 0 somewhere in between. So you have f of a and f of b. That's what's called intermediate value theorem. Somewhere in between, all y values are covered if you're continuous. There's a question in the chat. If you had a more complex function, would you factor first for making a table? How do you know? I won't do a more complex function, just so you know, because I really want to make sure you're using the theorem, so don't worry about that. Honestly, when you're making the table, a lot of it's just intuition. You could just graph in your calculator if you want and just see where one's positive, one's negative. To be honest with you, just plug in 0, because it's either going to be positive or negative, right? You know, just plug in 0, see what happens. And then maybe just plug another number bigger or lower, and you'll find it. Use a calculator if you need to. It's not a big deal. That shouldn't be, you shouldn't let that hold you back. So you can use a calculator if you want to. Just know how I would grade this. I probably give you a point for maybe this part here. Or maybe this would count as like 1 point total. Probably do another point here. Probably make this worth 2 points. Think of those 2 values there. And I'd probably make this worth 3 points. So something I'd probably make is an 8-point problem. Or maybe I'd make, you know, 1 point, 1 point, 1 point, 2 points, 3 points. Just, you know, that's how I probably would assess it. So that's the rubric I probably would use for that. And so if anything, those parts are kind of missing, of course, you do lose the appropriate number of points. On the AP exam, just so you know, all this counts as 1 point. All this counts as 1 point. And they don't do partial credit on the AP. So if you didn't say the continuity part, they'll give you nothing. If you didn't say Ivt, they give you nothing. I instead, I'm a little more granular, so I'm trying to help you. But those are the 3 things you need to have. They actually do ask for the graders, ask for those 3 things when they grade AP. And my guess is this is something they'll probably will ask on the free response. But that's all stuff we'll practice down the road. Okay, you guys got to do some work. So let's let me stop this recording, put you guys in breakout rooms. So we'll do breakout rooms for about 20 minutes. We'll come back. So you guys are going to do this.